managed to get our atmosphere looking better than ever. But there's still some broken stuff about the clouds, and I still have some thoughts on some stuff I want to do to try and improve the cloud rendering. So, oh, and then I've still got this bug, and I really don't know why. But I am curious. Maybe we can. So it seems to happen when rapidly approaching the planet. So let's try to isolate if it has to do with the um, mesh planet actor or the atmosphere. So like turn off one, turn on the other. See if we can replicate it. Plus, I need something for TV. All right, so let's turn off the mesh planet actor for a moment. Turn up the camera speed. Oh, and let's turn this off too, because we're still calculating the mesh even though it's not active. All right, so I actually don't think it's this. All right, so that's not causing anything. And now if I turn off the post-process volume, this won't cause anything either because we don't have ticket editor turned on, but if I turn it back on, we're probably going to get the error. So in the real-time mesh stuff, probably. Although nothing yet. Eventually we'll need to put some kind of throttling system in place to have like maybe tickets from a central location that get passed out for rendering. And while the tickets are out, you can't render your chunk or something like that. It's not erroring with this. Alright, turn them both on. Maybe it's a conjunction of using a complicated ray marching with the complicated mesh generation. Or maybe it's just not going to error out anymore. Alright, well, whatever. So let's see here. I really like that they've added an editor to the material. Look at this monster. So let's take this as it stands right now. Save it. Let's go ahead and update our version over here. And I want to try a couple things. Copy this whole thing. All right. So calculate array segments. Start position. Array direction. Planet radius. Atmosphere radius. Planet radius minus planet radius times so trace cloud segment. We're gonna need a load 3 trace sphere segment. Segment struct array. Max distance. float ray length equals ray dot p1 minus ray p2. I'm going to try to get the atmosphere on this tracing paradigm that I've come up with that has like consistent sample distances and traces it in a shell instead of a sphere, because there's a lot of wasted samples when you trace in a sphere. We might be able to get away with less. Actually, if ray length greater than equals less than or equal to 0, break mode 3 output at 3 0. I'd kind of like to get all this logic down here converted into a more concise form. Ray length divided by allow me equals length, camera position, ray dot p2. If this is less than next. Okay. So these are our accumulation values. We actually want these at the top. Array Oz. For 3 ray direction equals ray dot p2 minus no, was look at our trace clouds method because it's going to be exactly the same ray marching loop. This too. Yeah, it's p2 minus p1 normalized. And then after we get it, if the whole ray, this is checking to see if the whole ray is behind the camera. And if the whole ray I actually don't think we can use this here. I was just thinking Hang on a second. No, we check. Okay, yeah, that's right. We check the light separately inside us of another loop, so it does actually make sense to check that. But for this one, it's used in the skylight function as well with different inputs, and that might cause a problem. Let's leave it out for now. Come back to it. Oops. No, not here. All right, array position is equal to our array dot p1 plus um, array direction times float I times step length. Interesting. Just looking at what's going on here. So like this is all code that I've converted from another shader from Shader Toys. So I haven't deep dove on explicitly what's going on. So we don't actually use this. I don't believe this was something I added. We may want it eventually again, but we don't need it right now. All right. Let's change the name of this to density Sample position density sample. I I don't like names like pause I, pause L. I would rather have explicit longer names because I'm a big dummy and I need them. In, in position. God damn it. Position if we need it. I think I actually want to do this like this. Density. Okay, that'll work. I think we can actually leave this. Why are we multiplying? All these little pause eyes. Are actually the density sample position. Yeah, I see. And when it's all done, we do these things. So we need another struct. Struct. We need total ray, total MIA, probably total density. Total ray, total MIA, optical depth. Something like this. Guess I don't need total density. Result. Calculate scattering 2 then becomes segment data R1 equals uh, restruct 3 atmosphere segment. Optical depth. Altitude. I think that's right. Were those float threes? Yes. All right. So now we're right here. We should be able to get rid of all of this down to right here. Getting rid of all the cloud stuff for now. And if I can get this working like this, then it may be easier to incorporate the cloud stuff into this loop to be able to use the light data, which is kind of the goal. The way it works, yeah. I see. Okay, that's why they were in this order. Okay, so undeclared identifier A. L steps. The L. Ready, pause, I. Don't need that anymore. Don't think. array. Yay. At the very least, we did something. Alright. Well, that has sufficiently fucked things up. Should be zero, right? So here's what I want to do. I want to change it back briefly. Okay. Now, all right, great. So we don't have to blend scene color there. That's good. Okay. We're gonna fix this depth stuff. We have some depth issues with clouds when they encounter like mountains. We're gonna get it on the same scale as the atmosphere. Alright, alright. Tell me. All of these seem fine. And then we come down here, we sum them. Seems right. Mm-hmm. All right. I don't know why that doesn't work. Actually, hang on. Okay, yeah, there's nothing in here either. Just making sure. Hmm. Hmm. has. We'll probably need to break it down a step at a time. Ring length X, step size I. It wasn't doing this before. The hell? There it is. Alright, so let's just try in our calculate scattering 2, just returning some of our stuff. Like, we have total optical depth. Oh, god damn it. Shit. Okay. Oh, we got the crash. God damn it. Alright. I'm gonna have to track that down eventually. Yeah. Pick and editor off. Okay. Not doing anything currently. Hmm. No, not enough. Uh, I think it's too fucked. We probably want to just start again. Oops. Transfer this back over here. For one thing, we can replace this with density steps. Wait, no, we can't. Because don't. Hang on, let's check skylight. Yeah. Skylight is feeding it custom steps that are lower quality. Oops. Oops. Alright, this does annoy me, so redirection, start position, start position, start position, radius, radius. 3 ray and 3 start position for radius. Oops. Float for A, B, C, D. Ray, sphere, lambda A. Racer 1 dot Y. Don't save it yet. Let's test it and see if it still works first. Wood 4, ray, sphere 2. Racer 2. Light. Direction. Pause. I. Hemisphere radius. -2 dot Y. -2 dot A. -2 dot X. I think that's got it. Okay, excellent. Clean up these redundant racer intersects. So yeah, we might actually be able to accumulate the cloud segments by tracing between the start and end position if either one overlaps with the cloud boundaries. I guess we'll leave it. Um, this is like when you come inside the atmosphere, we start applying the atmosphere scattering to the clouds. I'm gonna try something else one more time that I did before. Comment this out. Copy this. Cloud scene. Change the atmosphere to scene color and change this to cloud scene. Step size L. Because maybe the attenuation on the clouds isn't such a bad thing. Yeah, so you get this unfortunate effect, which is what doing it the other way was all about. Alright, yo, what up? So, my dude, we're just trying to get this all polished up. This atmosphere and cloud shader. Because I converted everything to Unreal Engine 4 and it broke some of the stuff. So, yeah, we're gonna go back to the way I was doing it before. With the lerp, like as you go into the atmosphere, we apply the scattering to the clouds. Ah, fuck me. There we go. So now from space, the clouds are white. And approaching the atmosphere, they're still white. But then by the time we exit the lower layer of the clouds, we're getting the scattering. And yeah, there is this slight inconsistency here where, like, after a certain point, they're fully white here. But that seems pretty minor, to be honest. Seems pretty minor. I think it's fine. But on the other hand, this, like glowing edge on the outside where it's not overlapping the planet, is a problem. I may need to just apply like a literal, like, distance fade from this side of the planet, from the lit side, to darken the clouds. They probably look okay when you're in the atmosphere. No, they're still a little fucking bright. Mm-hmm. Oh my goodness. Sorry guys, I wasn't reading the chat. But so yes, basically I thought that if you ever seen Space Engine, I thought that was really cool and would be a fun project to kind of undertake something along those lines, just to stylize Space Engine. So I've been working on the Planet Tech, and this is a procedural planet. Right now I have it turned off, but I can come over here and do tick an editor. And now we get a lot of updates on the planet based on the camera position. So um, there we go. So you can kind of see that occurring here as we go down closer and closer to the surface. We get our updates. And I've been working on the atmosphere and clouds for the past couple weeks, um, because the default sky atmosphere and clouds look really great when you're on the surface of the planet, but they're not super great for being able to just seamlessly transition between ground to space. And I want to be able to do ground to space and star to star and galaxy to galaxy with no load screens. That's kind of the goal. Um, so this is kind of me working at the very small end of things. And then at the big end of things, this is fun. This is the shit. So it doesn't have any of my recent levels because I have recently migrated this thing. So I actually migrated it because this weekend I intend to. They added directional gravity support to like all the pawns and shit. So right now I have gravity, but it only really works for my space flight pawn. Um, so like you can see I'm accelerating towards the, like you can see on this left side it's just an output of like our kilometers per second basically. Um, and so we do have gravity, but we don't have like if I got a third person character and tried to walk on the surface of the planet like near the equator, you would it wouldn't work. Um, so I wanted to migrate to 5.4 so that this weekend I could go fuck around with their directional gravity stuff changes they put into play, which should allow me to use the actual like third person component and walk around on the surface of the planet, which should be fun. But like so, this is my air quotes small scale, which would be like planet scale stuff. But the real kind of idea behind this is uh, the idea of kind of this way you can represent a universe scale coordinate system with precision by kind of leveraging the relationship between distance and scale and speed. And I'll talk about that after I find my visualization level. Here we go. For the augury data. So I have another, like on the very large scale, like universe scale, I'm just generating some voxel data into various octrees of different scales. So we'll go ahead and let that run for a second. And hopefully it works because I haven't ran this level since I migrated it. Oops. Um, oh, you know what? I'm not running fast enough. We need insanely fast camera here. Like insanely fast because we're at like literal universe scale. Okay, so it's broken my ability to transit around, unfortunately. PP spaceflight. Yeah, but I'm not using spaceflight pawn 2. Um, hang on. Simulate. Okay, now I hope it'll work. Okay, yeah, there we go. So, you could envision each of these blobs as like a galaxy, right? And we're going like insanely fast right now. So I have some basically normalized point cloud functions, and you can decompose these into octrees of different sizes. So like the octree containing all of these, which would be like our galactic cores, is very, very big, right? It's like actual, almost the size of our actual universe. And then this galaxy that I have populated as a demo is about the size of a galaxy. And then this point in the galaxy is where'd it go? Shit. Here. This point. Fuck. Now I'm too fast. This is the problem. There we go. All right. Slow it down. Is about the size of an actual star system. So this is just kind of a demo of it, and you can see it kind of jittering here. That's because of precision issues. So what I want to eventually do, paint, is I want to take my very big octree of shit, and then my slightly smaller octree of like galaxy size shit, and then my actual like star system sized octree of like planets and individual stars, right? And you got to think that if something's really far away, okay, here's a hypothetical that kind of illustrates the idea. If something is, if the sun was half the distance it is from the Earth, but it was also half the size it is, and you didn't have to worry about like radiation or anything like that. From your perception, it would look like it was the same size, right? So the idea here is that you can have your solar system sized objects in your actual game space because with the very large coordinates you can represent about a small solar system. So all your planets and stars and shit, all of that is in the actual game space, right? But then your galaxy is in another octree, and let's say your galaxy is going to be 10,000 times bigger than your star system. Well, you can make your galaxy actually the same size as your star system, and then you have to scale everything with that, including the motion, and you represent everything except for the stuff that's in the very smallest uh, octree gets represented as particle systems. And as the player moves, so now imagine the sun scenario again, right? You have a sun that's now moved halfway to the Earth from where it was, but is also half its size. You standing on the surface of the Earth, you can't tell that that sun is a different size. But if you started moving towards it, you would quickly realize that you're approaching it faster than you should be because it's half the distance away from you, right? But let's say, imagine you've got your half size sun here, you've got your curved earth, and you're standing right here, right? From here, you can't tell that this is a different size, but if you start moving towards it, you can tell because you're approaching it faster, right? But what if, as you're going this way, this is moving away at 50% of the speed that you're moving towards it? Well, now all of a sudden it takes you the same amount of time to get to it as it originally did to get to the fully distant star. Um, and you now cannot tell the difference. You can't tell that it's smaller than it should be. You can't tell that it's half the distance away from you because as you move towards it, it's treadmilling away from you at 50% of the rate that you're traveling. So it still takes you twice as long to get there. So that's like the basic idea at like a very large scale of what I want to do, which is be able to like rig up all these particle systems, have them move kind of relativistically with the player's motion, and then when things get close enough within certain bounds of like the solar system sized objects, you start spawning them into real space. And so this is like this stuff is working from very high, like the very large scale. As you can see, like our little solar system of voxel cores here. Uh, and then the planet, which is where I've kind of been honestly for the past 3 or 4 months, is working on the planet tag, is working from the bottom up, right? Like I need like just having dots in a spiral galaxy formation is cool, but I need to be able to spawn actual procedural content in these locations. And each one of these voxel cores contains like seed data and things like that. So you can always initialize the same solar system for a given point. You can always initialize the same galaxy point cloud for a given galaxy point. And then, like, when you get down in the low level, you could always initialize the same star and planets and things like that for a given subset. And this is kind of like I've always been kind of fascinated with kind of the fractal nature of reality, and this is kind of my fun project to explore that stuff in, right? So that said, time to go back to grinding on fixing my cloud shader and atmosphere shader. So I've almost got it done now. Oh yeah, we're way faster now. So I've kind of been deep diving on ray marching for clouds and shit, and the atmosphere shader and all that stuff over the past, I don't know, way too fast now because I was traveling around at like universal speeds. So yeah, that's like the yeah, so that's like the kind of uh elevator pitch for the project. I don't have like a game in mind for it. It's more of just like a playground for me to fuck with shit that I find interesting. Oops. I still have a bug. I think actually a real time mesh plugin is crashing every now and then. Like this, perfect. And it's a pain in the ass to track down because it's literally just a stack of shit that doesn't really give you any clues to what's going on. So I have to track this down too. This wasn't happening in the project in 5.3, but it is now. And it just hoses it. So we got to restart at this point. But yeah, I'm trying to clean up kind of. Well, what I wanted to do is right now I have to do my ray marching twice for my clouds and my atmosphere, and I haven't been able to get them both working on the same ray marching paradigm, I guess. Like, so for the clouds, again, let me pull up paint. So the way the cloud ray tracing is working right now is I have two radiuses, and we do a line trace. Oops, there it goes. And like we got our camera location or camera location, and the camera has a facing direction, and we do our line trace through these two shells, and it always generates two segments. So in this case, our two line segments that it spits out would be this. In this case, it would be this. And in this case, it would be this split in the middle. And we just always split it into two so that it's like consistent behavior. And then what we do is, based on where the camera is, we start at the beginning of our first line segment, and we step through the material until we pass the camera location, and then we start accumulating cloud density. And that got past some issues with like the ray marching clouds flickering. God damn it, I'm too fast. Hang on. Uh, with like the ray marching clouds, what had a problem where because I was basing them on the camera location, as the camera would get closer, the samples would shift in location, and the clouds would be inconsistent because like your noise texture sampling would be like moving while the camera moves, and so you would get this kind of flickering effect. But by always starting with the discretely calculated segments, it always starts at the outer shell, not at the camera. You're able to make all your samples be at regular intervals, so they don't fucking jitter around while you're moving around the camera. And there is animation going on here as well. There's some subtle uh, subtle cloud movement in there. There's just some noise scrolling basically. And yeah, that's kind of. This is also like I'm not a game dev by trade, but this is all interesting shit for me, so I enjoy doing it. Um, but yeah, yeah, sovereign. I'm not. Are you talking about Oh gosh, what's his name? I watched a bunch of videos from Sebastian Leg, which gets you like the baseline, but none of the like quad tree planet shit. Like that was a whole thing, right? Because like it was one thing just to get it working with the quad tree LOD system and using the noise and all that stuff, but then to get it actually working in a way that was like fast enough to use it took like three times as long as it took to get it just like rendering the planet. Like to get the performance up high enough on this mesh generation logic to where it's like reasonable to use it. It literally took me three times as long as it took to like get the mesh generating at the start, right? Everything had to be asynchronized, had to be we have to generate all the mesh data off the game thread. um had to it's not I'm not using the procedural mesh component. There's a third party plugin called real time mesh that I picked up. It's free. It's just a GitHub thing, and I'm using Fast Noise 2 library for the noise, which was its own can of worms because it's a CMake project, so you have to jump through some bullshit hoops for that. But in the end, I am pretty happy with the performance of it. It runs reasonably quickly. And then we have some other stuff like, let me find it. This is pretty fun. We got the speed influence and gravity influence zones, and these need to be actually halved. And max speed limit radius also needs to be halved because I recently halved the size of the planet because I was testing something. And then gravity influence zone again, half. So this is what I was using to apply my gravity. And it's just using like a fall off formula. We calculate the mass based on the inner radius and some like real world math. And then you would get the actual gravity formula applied to you while you're in this sphere. And then this inner sphere. So you know how I think somebody just mentioned controlling the camera speed with an editor widget. Well, one of the challenges of this whole idea of being able to move really fast between shit is that, as you saw when we were in the other project, you have to go so fucking fast that like you literally don't have the ability to stop at the point you want to get at. So the speed influence zone is kind of the idea to help that. It's basically we can hard limit the speed, and hopefully it'll work here and not just crash with the bug that we just saw. Um, or maybe I just don't get my pawn at all. It was working a minute ago. Oh, you know what? There we go. So we got our little physics-driven spaceship here, and where's our planet? Okay, there she is. So this, what the speed limit zone does is it will pull us out of warp as we go really fast. So we're closing in, we're closing in, we're going 3,000 kilometers a second right now. We hit the speed limit zone, and now we're going like a manageable um, planetary flight speed, right? And so the idea is to kind of replicate that at various scales. So the same way I do a speed limit zone for the planet, I could do another bubble around each star system. And then the same way that you do a bubble around the star system, you could create a speed influence zone around the galaxy. And then you could have like a hotkey or a button combo that will warp you out of whatever influence zone you're currently inside of. And that's kind of the way I hope to be able to allow the user to move at speeds that would actually allow them to like get to places and land on things correctly. But hopefully this weekend I can get some spherical gravity working and create a little thing where you can like actually land the ship and hop out of it. Because right now, like I said, we got gravity and we got collision, but you could only walk around on basically the very top of the planet because otherwise you will fall off if you're using regular gravity. And if you're not using regular gravity, you just get a bunch of wonky bullshit happening like your character is on the equator and their z axis is pointing like down on the z axis in world space while the gravity is pulling them sideways into the planet, right? So that's what I'm hoping migrating to 5.4 will get me is basically kind of a lot of those pre-built character pawns and shit out of the box to walk around on the planet with. But yeah, so eventually we would exit back out of the speed influence zone of this planet and we'll start zooming away really fast. Right now we're at like 2 kilometers per second. And eventually we should be hitting it any second now. Yeah, there we go. And now we can go up to like 10,000 kilometers per second. And hopefully, like if we go too fast, we have to be careful with like the speeds that we allow them to go. Because if you go too fast, then you could still end up inside the planet, which I have a feeling we might here. Because reducing the planet size by half probably also reduces. Oh no, it worked. It worked that time. All right. But yeah, that's like the quick bird's eye demo of my project and where it stands currently. All of this stuff's custom made. Yeah, I was just hang on. Let me catch up here. Oh yeah, turning. I definitely want to look into the PCG stuff. I'm gonna use that eventually for foliage. I've just been kind of shying away from it because ideally I would like for everything in the game to be procedurally generated, right? Like I don't want to have of I don't I'm not like a GIMP master that's going to go crank out a bunch of really nice models and shit. Um so I figured, just terrain is probably good enough for now on the small scale because I want to get everything rigged up on the large scale, right? But once I'm done with that, I do want to look into like spawning PCG, like foliage and shit like that. But I know the reason I'm kind of leery to go down that field is I know that when I do that, I'm going to want to deep dive on like how can I procedurally generate trees? How can I procedurally generate different types of bushes? And that's like that could probably take you a year by itself. And yeah, if I got to the point where I had kind of accomplished my initial goal, which is like, so right now this is a skybox, right? We're not actually using like these stars don't really exist. But if I was in my other scene where we have the like very large scale stuff, in that scene every single star you see would actually exist and be a place you could go to. Um, so like right now I just have this scene because it helps, the earth look better. Like as I work on developing, this tech here, and you can kind of see the planet without the atmosphere here. We have like some custom noise formula that gives us some kind of neat mountain ridges and things like that. Um, And you can change the colors of this with just a couple gradients, is all it is. And eventually, this is all this stuff over here. Eventually, I would like to. Right now, the like randomization parameters for the mesh height map are all set up in a in a big struct. So we go here, we come down here, we can start fucking with the planet attributes. So, well, for instance, just the quickest, most obvious one is like, let's put a random seed in, right? We get a different planet, different planet, different planet, different planet, different planet, right? And as you randomize the seed, you could also randomize the color height maps, or the color gradients that you're using for the height maps and the biomes. Um, but we also have stuff like noise scale point 0.1 will yield a much more varied height map here. Now, I haven't, none of this stuff is rigged together properly with the materials, so I would also have to go update this value in the material, which I'm not going to do right now. Um, right now it's on point 0.03. Or, oh, I forgot. I can't do that. I have to set it. Yeah, it's fucked now. So yeah, there's certain amounts of polish that need to be done, and bug crushing. I have at least the one new bug that we already saw once. This is a different one. You can't like drag the sliders on the actual mesh parameters because it attempts to destroy and generate the mesh every time like it's ticking basically, and it just craps out when I try to do that. But you can punch in the numbers one time and hit enter and it'll work. You just can't drag the slider around. But we have a bunch of, so like basically we have a noise formula with this mesh planet. Oh, and then the other fun stuff that we can do is like we can control the subdivision level. So I don't usually do this because it runs slow when you're at the surface level, but if you were out on foot, you can actually get a really high, really deep on this LOD level. Like right now I have 13 levels of subdivision, and as long as you move slow, it'll work just fine. Get rid of the atmosphere for the moment so that we can look at just the planet. So yeah, you can get it quite detailed. So like on foot, you might turn this up. Generally speaking, I leave it on like a 10, and that's good enough for like debugging purposes. You can turn it down. You can make it not tick in editor so that these updates don't happen. Planet attributes. Where's my freaking mesh parameters? All of this stuff's broken now because I've made this whole new atmosphere system that's not rigged into it yet. Okay, okay, so like we can change these scales and it'll change the basically parameters that are forming the planet, right? I think it was at 0.5, 1, 2, 1, 0.1, 2, 1, 0.75 is where we're at. 1, 2, 0.1. So all these can be randomized, and they all do different things. Okay, so what I was getting to is the idea that eventually want to do is rather than having one noise formula, which right now I have my noise formula that generates a Terran like planet, like a Earth like planet, right? Um, Rather than having all these noise parameters, I want that noise function to be encapsulated so that I only give it a few things, like seed, whatever. And then that noise formula gets a name like Terran Planet Noise Formula. And then I could go make another noise formula that's like a airless rocky planet with a bunch of craters and shit, right? And that would also be encapsulated. And then I just pass to this planet generator whatever noise formula I want, and we can randomly pick between them. Like, oh, I want an airless planet for this one. Here's this one. Oh, I want a lava planet. Use this noise formula. Oh, I want an ice planet. Use this noise formula. And we can kind of create different archetypes of both noise formulas and then biome gradients. Um, so our planet's actually made from two gradients. We have a foliage height gradient. It's actually a foliage height temperature gradient, and then a ground height temperature gradient. And then we create procedurally a temperature and a moisture map that determines what areas are going to get foliage, what areas are going to get ground, based on in what color, like what temperature that stuff's going to be, based on where it's at on the planet, and some other factors like that. So, like, if I wanted a different planet, I might actually be able to change it. Yeah, here we go. Um, so say we wanted to do one with water. Okay, now I'm confused. Oh, you know what? I turned this off too. Oh man, I turned all this off because I'm in kind of the process of taking all this shit apart and putting it back together again, basically. Uh, 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 okay. Empty mesh planet. Where's the stupid gradients? Oh, actually, it may be okay. I take it back. That is still being set procedurally here, probably. Yeah, right here. And no? Well, pardon my confusion on why my shit doesn't work the way that I think it's supposed to work. I'm bamboozled. Okay, so where are my freaking height maps coming from in that case? Base color. Blurp. Ah, here we go. Alright, great. Great, great, great. So now I can show you what I'm talking about. So let's get extravagant with it. Let's say we wanted a lava planet. Not a kava planet, but a lava planet. Um, lens, lava one. So now, we got something that resembles like a. I think I've got them flipped. Like, it should actually be like this. But yeah, you get the idea. Like, you can get a dramatically different appearance with just two different gradients. Um, the reason I use the Terran ones most of the time is because I haven't actually refactored most of these gradients into the format that I want them in. These included like ice. We got an ice planet. But like most of these actually have oceans on them, which is what I'm kind of trying to get away from because I'm currently working on some ideas for ocean simulations for the whole thing. But here we go, like Terra foliage. So here's Terra with an ocean. Or at least it's not really an ocean, it's just a height map. But eventually I want to do like some either FFT ocean or something along those lines. And then I turn this guy back on. Now I can just go on down to the surface. You get with the noise formula I'm using, you get like some kind of nice mountain ridges on along what would be kind of fault lines. I'm not doing any simulation or anything like that. It's all noise based, but I did figure out some kind of hacky ways to get some reasonably realistic landscape features and variants. Um, it's actually kind of a trick. Planet surface. So the way the surface temperature works is we calculate just a random pattern from noise. Then we modulate it by the latitude by some amount, which is like a coefficient you can enter in. So it'll like decrease temperature as you approach the poles. And then we have like a fall off control for that. And then the noise is also modify it's domain warped. Yeah, that volumetric texture pack is probably one of the best things I spent money on, man. $5 for that pack has got me a long way. It's really nice. Um, and then you have finally you have like a master you have a master temperature slider that determines like basically your starting temperature that's modulated by the temperature map. And then also we have a moisture map that's being calculated in a similar way. We're using domain warp noise to kind of try to represent like kind of trade wind patterns, and your temperature changes. If we look at the texture, so let's take a look at this guy. So this is my ground texture. So your temperature as it approaches zero is sampling from the y-axis, and your elevation is sampling from the x-axis. So as your temperature for the planet gets lower, and your elevation gets either lower on the ocean side or higher on the planet side, you get more snow. Um, and then likewise, if we look at the foliage map, likewise, temperature, as we decrease the temperature, we're sampling lower on the y-axis, elevation on the x-axis, and then the moisture map lerps between these two different gradients. So both these gradients are getting sampled by the same way, texture on the y-axis, elevation on the x-axis, and then they're lerped together, like the output of both those operations is lerped together by the moisture map. And that's how I do my planet texturing. Swing systems. Yeah, it's just fun. Like I don't necessarily need it to become a game that I'm gonna sell or anything like that. It's a hobby for me. So I just I really like deep diving on shit. I like, okay, I'm gonna like rather than the traditional game dev kind of mindset of like, oh, we got something that works. Okay, move on, do the next thing. Yep. Oh, like, okay, we got something that works. Move on to the next thing. We're gonna go as fast as we can. I like to, for my hobby, I like to pick something and be like, oh, okay, let's generate a planet. How can I do that on par with like a AAA game studio? And I don't care how long it takes me to figure out how to do it. And then I go deep dive on that for months and months until I come up with something that I like. And I'm like, oh, atmospheres? Okay, like because I had an atmosphere before that was just like basically it wasn't doing any kind of like physically based shit, like no scattering or anything like that. And but I wasn't satisfied with it because I wanted to look good, you know what I'm saying? I wanted to be like damn. And I don't care how long it takes because I enjoy the process. So like that's kind of why this is a fun project for me, because it's like there's an infinity of things to do and learn how to do. You know what I'm saying? And I could deep dive on whatever I want. And it's a part of the universe somewhere. There's an issue with my depth mapping here too, which is weird because the same logic works in the atmosphere shader. So like some of my logic actually okay, that's something that I can probably fix right now. Um there's something not quite right in my depth short circuiting for the clouds because they shouldn't be cutting off like that. So I need to go look at trace cloud. Here it is. That seems to make sense though. If the length of the camera's position minus the current position is greater than the scene depth, break. Well, shit, I thought maybe I wasn't taking the camera position into account here, but it seems like I am. How do I handle it in the atmosphere? Oh, can I just say, thank God they added this, like, window for editing the HLSL code. It is so much better than it was trying to like fuck with this little box, which is just so obnoxious. Max distance. I see. Yeah, I see. So they're setting that like so I came up with a way to convert. I don't know if you're familiar with Shader Toy. Yep, later dude. But I feel like, yeah, so this is basically converted from a MIT licensed shader I found on Shader Toy. So, like the clouds I wrote myself with references, but like I wrote this block of shit. But the actual atmosphere calculations I didn't write. I just converted from GLSL to HLSL and then formatted it so that Unreal could use it, which basically just involves putting all the functions that you want to use in a struct and then putting all the global values that you want to use outside of the struct and then initializing the struct and setting all the global values that you need before invoking it. I'm actually getting pretty sleepy myself. Almost 4 a.m. So, two. And of course, my favorite thing to do is because all of this shit's physically based now, we can do stuff like go into the atmosphere parameters and grab our Raleigh color and change our atmosphere color to whatever wacky color we want, which is a lot of fun. And then because it's all physically based with scattering, oh, no, there's the bug again. You know what? I think that's my sign to retire for the evening. So appreciate everybody watching, and later, guys. See ya.